During the Battle of Britain, the Hawker Hurricane proved a tenacious warrior, holding its own against Germany's best fighters. But soon, tenacity would not be enough to guarantee survival. As ever faster German fighters rose up against the RAF, the less agile Hurricane was clearly outmatched. For the Hurricane to remain relevant in the struggle against Hitler, Hawker would have to reinvent their sturdy fighter. Introduced in the spring of 1942, the Hurricane Mark II-C was the most heavily armed single-seat fighter in RAF service. Its four 20mm Hispano cannons packed a considerable punch. Analysis from the Battle of Britain showed the .303-inch machine gun armament to be clearly inadequate. German bombers, like the Junkers Ju-88, were difficult to shoot down. Equipped with self-sealing fuel tanks and armor plate, they could absorb a vast amount of .303-inch ammunition and remain flying. The new Mark II-C packed a hefty punch. Total rounds carried was 364. Pilots were told to fire short bursts only. Long bursts would slow the aircraft down considerably. One can only speculate as to what the results might have been if the Hurricane had been equipped with 4 cannon during the Battle of Britain. The Mark II-C was also modified to carry a pair of 250 or 500-pound bombs, or a pair of 44-gallon drop tanks. The increased armament offered the Hurricane a new lease of life. By the autumn of 1941, the Hurricane's performance shortcomings excluded it from most daylight operations, but their numbers continued to increase. 57 home-based squadrons were now equipped with Mark II-Bs and Cs. June 10th, 1940. Italy declares war on Britain and France. In North Africa and Egypt, the RAF's total fighter force consists of 3 squadrons of Gladiators and just 1 Hawker Hurricane. On the strategic island of Malta, 4 hastily assembled ex-Fleet Air Arm Sea Gladiators are all that stand against the Italian Air Force. On June 21st, 8 Hurricanes are ferried to the island via France. Shortly after, France surrenders, cutting this line of supply. To keep their lines of communication open, the British had to find a new way around interfering German or Italian forces. For the British, their advantage lay with their colonial possessions. Takoradi, 1940. Gold Coast of Africa. Preparations begin on a new airstrip. Takoradi would be the first stepping stone in a long ferry route across Africa to Cairo and Egypt. It was a hazardous journey. The first Hurricanes arrive in September 1940. Shipped straight from the UK, these crated Hurricanes were quickly offloaded, reassembled, and made ready for flight. After reaching Cairo, the ferry pilots would return to Takoradi aboard a BOAC Lockheed Lodestar or RAF Bombay transport. Prior to America's entry into the war, thousands of Americans would volunteer with both the RCAF and the RAF. The result was the first of 3 Hurricane-equipped Eagle squadrons. The initial squadron, number 7-1, formed in September 1940 and saw action in February 1941. 2 other squadrons would follow, and in September 1942, all 3 were officially transferred to the USAAF, becoming the 4th fighter group. Pearl Harbor, December 7, 1941. America and Britain are now at war with Japan. To strengthen the air defences of Malaya and Singapore, 51 crated Hurricanes are sent by sea, arriving on January 3rd. With its reputation still glowing from the Battle of Britain, it was expected the Hurricane would sweep the Japanese from the sky. That optimism was short-lived. The Hurricanes that arrived on January 3rd were not assembled until the 19th. By that time, Japanese forces were swiftly advancing down the Malayan Peninsula. In the skies above Malaya, Nakajima Ki-43 Oscars and Mitsubishi A6M0s quickly overwhelmed the small Hurricane force. By January 28th, of the original 51 Hurricanes, only 20 were left. On February 10th, the last 7 Hurricanes flew to Sumatra. 5 days later, Singapore surrendered to the Japanese. North Africa. Since March 1941, British anti-tank weapons had proven inadequate when dealing with the German Panzer III and IV tanks. The new 57mm anti-tank gun was in short supply. As army commanders pressed for a solution, the RAF offered the new Hurricane Mark II-D, the world's first anti-tank fighter. Armed with two 40mm Vickers S guns, the new Hurricane was capable of defeating any tank when attacking from the side or the rear. The Vickers S gun rate of fire was 100 rounds per minute, with a muzzle velocity of 1,870 feet per second. Each gun was equipped with 15 rounds of ammunition with a mix of high explosive and armor-piercing rounds. By the winter of 1942, the situation in Africa had settled down to an uneasy calm. During this period, No. 6 Squadron took delivery of its first cannon-armed Hurricanes. Urgency was paramount, and pilots immediately began low-level training. Testing revealed that in order to achieve success, it was necessary to approach the target horizontally and at very low level. To help with their aim, tracer ammunition from 2 Browning machine guns was used to judge distance. The captured German tank served as target practice. When these tactics were tried out during Exercise Spartan in March 1943, the results were very poor. This would be in sharp contrast to the outstanding success achieved with the same aircraft in the Western Desert. From June 1942 until May 1943, No. 6 Squadron flew a total of 319 anti-tank sorties. According to official records, 47 tanks, 5 armoured cars and 3 half-tracks were destroyed. Often, hits from the 40mm cannons only disabled an armoured vehicle. 126 other vehicles, including 103 trucks, were also hit or destroyed. But it came at a price. 47 Hurricanes would be lost, with 40 being shot down in action and 5 pilots killed in combat. Only 1 was shot down by a fighter. It was clear. Low-level ground attack was dangerous and costly. Unfortunately, the urgent need for new tank busters in North Africa left little time for the application of additional armour protection. The Hurricane's liquid-cooled Merlin proved extremely vulnerable to ground fire. A single rifle-caliber bullet in the oil, glycol tank or radiator was often lethal, especially at low level. The tank-busting Hurricane had other limitations. As a specialized weapon, targets were limited. The combat situation had to suit tactics as well. If tanks and vehicles were not caught out in the open, the tank-busting Hurricane would sit idle. By the end of 1943, 800 Mark II-Ds were delivered. While No. 6 Squadron's exploits were well known, 3 other squadrons, all based in England, used the tank-busting Hurricane with varying degrees of success. As a pure fighter, the Hurricane's performance no longer matched the newer Bf-109G or FW-190. Their lack of speed was not Hawker's only problem. It no longer made economic sense to build and construct Hurricanes as frontline fighters.
Development of the Hurricane during the war was limited in part by the aerodynamic limitations of a thick wing, and in part by how labor-intensive it is to build a steel frame wrapped in a wooden structure, wrapped in fabric, and it took a lot of materials. There were people looking for Merlins, for Mosquitos and Lancasters and Spitfires and Mustangs, and so because of all the resources it took to build the rest of the airplane and its aerodynamic limitations, the Hurricane quickly slipped to the end of the list for priorities.
Even with these drawbacks, the Hurricane continued to fight in some new and unusual roles. One of the most outlandish was the Cat Fighter, or Hurricat, a seaborne fighter rocket catapulted from a ship to provide convoy protection. German long-range FW-200 Condors, in combination with U-boats, were taking a heavy toll of British shipping. To counter the threat, 35 merchant ships were converted with a single Hurricane and catapult system. These ships were designated Camm ships, catapult-assisted merchantmen. Camm ships and their Hurricanes would shoot down at least 9 FW-200s for the loss of just one Hurricane pilot. Unfortunately for the pilot, once the mission had been completed, he had to either ditch the aircraft or bail out close to a friendly ship. When the Royal Navy entered the war, its aircraft carriers were equipped with a mix of multi-role bomber and torpedo aircraft. There were no single-seat fighters. Desperate for a shipboard fighter, the Admiralty turned to the trusted Hurricane. The first Sea Hurricanes, equipped with an arrestor hook, were designated Mark 1Bs. Sea Hurricanes saw action in the Mediterranean, Atlantic, and Russia. It was, however, not the ideal fighter for the job. Without folding wings, it took up a lot of deck space, and its overall performance was lacking. By 1943, the Sea Hurricane was replaced by the more capable Grumman F-4F Wildcat, a true naval fighter. In the end, 1,200 Hurricanes were converted for maritime use. By the summer of 1943, the Hurricane was withdrawn from service in England. Hurricane units began to receive a new Hawker fighter, the Typhoon. Powered by the 2,000 horsepower Napier Sabre engine, the Typhoon was fast and heavily armed. Like its predecessor, Hawker had designed the Typhoon with a thick wing. The Typhoon's performance at altitude was disappointing, and like the Hurricane, it soon found a role as a deadly ground attack fighter. Armed with 8 air-to-ground rocket projectiles and 4 20mm cannon, the Typhoon proved to be one of the most devastating ground attack aircraft of the war. The Typhoon would be followed by the even more impressive Hawker Tempest. Equipped with a thin laminar flow wing, the new Tempest was a great improvement over the Typhoon and was considered one of the best low to medium altitude fighters of the war. September 7, 1942. The government's chief scientific advisor, Sir Henry Tizard, states, "The Hurricane has certainly outlived what everybody thought would be its useful life because of its value for aggressive action against land targets." The key to the Hurricane's survival was its thick wing and the development of new weaponry. Bombs, rocket projectiles, and large caliber cannon were the ingredients for this renaissance. The Hurricane's thick wing, which even Sydney Camm regarded as a cause for regret, was now one of its best assets.
I don't think the design of the Hurricane's wing ever anticipated the additional stores, bomb racks, rocket projectiles, or even external fuel tanks that grew into the airplane over time. It's because it was a thick wing that it had a lot of structural margins, and it was relatively easy to retrofit these things. As well, the thick wing had the advantage of making the Hurricane obsolescent in terms of fighter performance, in terms of speed, early in its career. And so, having tooled up to produce lots of Hurricanes, it became an easy design choice to press them into service as a ground attack airplane, for which it performed admirably when it was no longer really an air superiority fighter.
One of the problems with the Spitfire was the wing wasn't thick enough to find a good solution for both putting retractable gear into the wing and also putting the armament you needed. It was much easier on airplanes with a thicker wing to put the fuel tanks and the armament and the gear retraction.
The Hurricane, armed to the teeth with weapons, fought bravely on. Number 6 Squadron, newly transferred to the Balkan Air Force, would prove to be the longest-serving Hurricane squadron in the RAF. With just a week before Germany's surrender, the Hurricanes of Number 6 Squadron attacked 16 German troop ships in the Gulf of Trieste. War for the Hurricane in Europe was finally over. As the role of the Hurricane faded in Europe, on the other side of the world, the Hurricane would battle on to the bitter end. After the fall of Singapore, British and Indian forces would continue to fight Japanese forces in Burma. The Burma campaign was one of the longest of the war. During the summer of 1942, Hurricanes began to arrive at a rate of 50 a week. By September 1943, the RAF had over 1,000 Hurricanes in theatre. But victory would not come easily. Spring 1944. The Japanese prepared to invade India. By March, the Imphal Plain and the garrison town of Kohima were surrounded. Here, RAF air superiority won the day. While Spitfire Mark 8s cleared the skies of Japanese fighters, 10 squadrons of Hurricanes hounded the Japanese forces below. By July, the siege was over. Over that period, Hurricanes flew 6,000 sorties. In the final months of the war, the Hurricane was replaced by Spitfires and the massive P-47 Thunderbolt. When Japan finally surrendered, 3 squadrons of Hurricanes were still in frontline service. Armed with cannon, rockets, bombs, and the newly developed napalm, the Hurricane remained a formidable weapon during the last 4 years of the war. Its versatility points to a fascinating paradox in the Hurricane story. For an aircraft of such a transitional design, the Hurricane was both modern and dated, revolutionary and conventional. At its core, the Hurricane was quintessentially British. A bulldog of a plane, it reflected the nation's wartime character: reliable, tough, determined. After the war, Hurricanes continued to serve. Amazingly, Number 6 Squadron continued to fly the Hurricane as an Army cooperation unit in Palestine. The Indian Air Force operated 2 squadrons until 1947. The Irish Free States Air Force kept their 13 Hurricanes flying until that same year, and Portugal used them until 1951. The last Hurricane to be built by Hawker, PZ-865, now flies with the Battle of Britain Memorial Flight. It also appeared in the 1969 Battle of Britain epic as Sir Keith Park's personal aircraft. The arrival of the new jet fighters, beginning with the Gloucester Meteor and the de Havilland Vampire, did not spell the end for Sydney Camm and Hawkers. Turning his attention to the new frontier of jet fighter production and design, Sydney wasted no time in producing the Hawker Seahawk. On September 3, 1948, the first prototype took to the air. In 1949, Hawker would receive an order for 151 Seahawks. The Hawker Hunter, the last in a long line of outstanding fighters designed by Sydney Camm. The genius of his design began with the Hawker Fury, the most successful biplane fighter of the 1930s. World War II would see the contributions made by the incomparable Hurricane, Typhoon, and Tempest. The Hunter was a Cold War classic. Considered by many as the best-looking and best-handling combat fighter of the 1950s, the Hunter would serve the RAF well into the 1960s. The crown in Sydney Camm's career would have to be the Hawker Siddeley Harrier. Far from the fabric and wood of the Hurricane, the Harrier was truly revolutionary. Powered by a Pegasus vectored thrust turbofan engine, the Harrier was the world's first vertical takeoff and landing fighter. Among all of Camm's rich achievements, the Hurricane has to be the most significant. Without his persistence, the future history of Britain, even mankind, might have been very different. As a tribute, Flight magazine said it best. Without detracting in any way from the magnificent courage, skill and endurance of the fighter pilots, the British victory was in some measure due to Hawkers, who produced the aircraft in time and sufficient numbers to enable the pilots to turn the day.
A lot has been said about the Hurricane, the Spitfire, and the Bf-109 in terms of which is the best fighter. And I think the most honest answer is that a good pilot will fly his airplane to its peculiar strengths and avoid being worked into a corner where he suffers from its weaknesses. And there were exceptionally capable pilots in Hurricanes, Spitfires, and 109s.
The summer of 1940 was a moment in which the world was convinced Hitler's Germany would prevail. It was the Hurricane that helped turn the tide. For the first time, Nazi invincibility had been defeated. The once distant hope for victory was now a clear and unstoppable reality.
Adolf Hitler, the Führer, dictator of Nazi Germany, along with Mao, and Stalin, one of the most evil killer leaders of the 20th century. The Treaty of Versailles ended World War I. The treaty stripped defeated Germany of territory, of weapons, and what was left of its economy. Hitler was provoked to write his book, Mein Kampf, in English, My Struggle, where he laid out his plan for a new world order. His Nazi Party would restore Germany and take over Europe. In fiery speeches, day and night, to thousands, he preached two great evils, Judaism and communism. Over 6 years, Hitler built an overwhelmingly powerful and tactically brilliant military force, ground, sea, and air. He took over Austria and Czechoslovakia, then in 1939 invaded Poland. Within 3 months, he crushed 6 countries, controlled most of Western Europe, and was knocking on France's door. In the spring of 1940, the Germans surrounded nearly 340,000, mostly British and French, troops. Their only escape was from the shore of the port of Dunkirk in northwestern France. The water was extremely shallow, so British destroyers could not approach the beaches without running aground. Well, Prime Minister Winston Churchill mobilized every possible private boat, over 700 of them, to cross the English Channel from Ramsgate in eastern Britain to the rescue. Pleasure boats, yachts, fishing boats, any boat with a shallow draft to navigate the shallow water and ferry troops out to the waiting ships, or sail them back to England. Over 10 days that spring, they became known as the Little Ships of Dunkirk and saved more than 338,000 British and French troops to fight another day. And that day came very soon, when the Germans began what became known as the Blitz, nearly 10 months of bombing Britain day and night, the Battle of Britain. Churchill, in one of his powerful radio talks, rallied his country. Heroes of the Blitz were 2 airplanes, the Spitfire and the Hawker Hurricane, and, of course, their pilots. They destroyed more than 2,600 German aircraft. Britain survived the Blitz and the Battle of Britain, but knew that new and more versatile aircraft were desperately needed to outlast and outgun Nazi Germany. The de Havilland Mosquito filled the bill. It was actually made of wood, the frame and the outer skin, so it was nicknamed the Timber Terror, the Loping Lumber Yard, and the Wooden Wonder. 6,700 were built during World War II. With a crew of 2, it was a day-night fighter bomber and photo reconnaissance aircraft, and very effective as a low-altitude intruder. It was the most versatile twin-engine plane of World War II. And it was the first twin-engine airplane ever landed on an aircraft carrier. The pilot was Eric Brown, call sign Winkle. He was Britain's most decorated pilot. He flew 487 different types of aircraft and performed more carrier landings than any pilot in history, 2,271. So, ladies and gentlemen, please welcome Warren Denholm and Stu Dawson and Sam Bass, my partner in crime out here. Either one. Sam, you at the other end? Yeah, the bookend was Sam there. That's good. Gentlemen, welcome.
Welcome.
Thank you.
Welcome back. Welcome back. Why was this plane needed as the war wound down?
Well, it's one of the most high-performance airplanes out there, and it's got the power and the versatility and the firepower to do just about anything that they needed to do.
But the fact that it's made of wood, how curious is that or not?
Warren, I think you can answer that since you built the airplane.
That's why you're only going to get two of those. Well, the airplane was built by de Havilland in England. So de Havilland had been working on a plywood composite sandwich construction for a few years before the war broke out, and they had this idea that to meet a specification that the British military had put out for a high-speed bomber, that if they could build it out of the smooth plywood construction, they could achieve the performance parameters they were looking for, and they could offer something that wasn't made out of aluminium anymore, and aluminium was going to become a very strategic product during the war because all the other aircraft manufacturers were pushing aluminium airplanes, and de Havilland could see that that was going to be a difficult product to get hold of, so they went for the wooden construction.
So what were the pluses and minuses? What was gained by its being made of wood, and what was given up, if anything, by its having been made of wood?
Well, part of the other concept that they had was that since the war had broken out, the King of England wasn't buying any fine furniture anymore, and there were a whole lot of little furniture manufacturers and piano makers and all these little businesses around England with a skill set of cabinet makers that were their abilities were no longer required, and so they developed the design in such a way that they could kind of move all different products to these little shops around the country. They could have the horizontal built in one town with one little company, and then bring it all together at the end. So that would sort of diversify the manufacture, utilise the skill set of these people that were otherwise not needed, and also make the airplane much quicker to build because you don't need a lot of a wooden airplane. Obviously, you have to have the basic skills, but most wooden components just start off as a drawing on a set of plans, and with rudimentary tools, you can kind of make anything. So it doesn't require a whole lot of heavy metal and dyes and special equipment that you would normally need for an aluminium aeroplane that has to go into a proper production facility. So it was quite a clever way of doing it. What did it give up? Well,
In terms of performance, I mean, yeah.
Oh, in terms of performance, well, I don't think it gave up anything. It's not necessarily lighter than an aluminium aeroplane, but it is definitely smoother. It has less number of components for any given sort of piece of construction. It's as monocoque as you could get. It only has 7 bulkheads down the length of the fuselage, and and a lot of other airplanes, you can't even get out of the cockpit and you've had 7 bulkheads. It's probably not as robust from a weathering perspective. You can't leave it outside without it suffering a little bit. But no, it didn't give anything up in performance.
What's it like to fly, Stu?
It's a little different than the aircraft that we're used to, but just systems and stuff and everything. And he's talking about performance. This thing, a Mustang has a hard time staying with it. I have to pull back on power so they can stay with me at cruise power. So it's slick. It goes through the air real well. This is a little bit bigger than a fighter, but it's a fighter. It can be. It can be a bomber. It's very versatile. You can't be a real big guy and fly because there's not much room in it, but it is a fantastic airplane.
And one person in the cockpit?
Well, usually they carry two. There's usually two seats up there, the pilot and the navigator, i.e. bomb.
Yep.
There's a bomb sight out front that he could put out and look for the bombs and everything, but it's so versatile and it will go.
To what extent can it bite you?
Say again?
To what extent can this airplane bite you when you don't expect it to?
There's a lot of stories about how the VMC on this airplane.
What's that mean?
VMC is the speed at which you don't have enough rudder to control the airplane with one engine inoperative, basically. And it's out there. There's a number out there. Everybody says 160, but unless you're fully loaded, with bombs and all the ammo and everything, real high gross weight, this thing doesn't have a problem at all. It'll fly at 140. You just pull the power back a little bit so you don't have so much torque. It's not as dangerous as people say it was. It's really, but the way we were flying them in World War II, any of these airplanes were overgrossed and it was a different animal. Yeah. It's a great airplane.
So where is this airplane from? This airplane. Tell us where it's from, how you found it, what you did with it.
Yeah. Well, this airplane was a Hatfield-built airplane from the UK. So they built Mosquitoes in England, Canada, and Australia. But by far the bulk of them were built in England. So this one was built at Hatfield in England and delivered in March 1945, so almost at the end of the hostilities. And it was delivered to an operational training unit that was training pilots for strike operations and long-range fighter missions. And it stayed with the operational training unit until the war ended. And then after the war ended, it was sent off to maintenance units for whatever they did at maintenance units after the war, practice polishing them or something, I don't know. It didn't really do anything much else. And then in 1948, the RNZAF in New Zealand, only coincidentally, bought or was sold from the British government a few more than 80 Mosquitoes. So England didn't really want the Mosquito after the war. The new jet airplanes like the Vampire and the Meteor and what have you were coming on stream. The Mosquito was kind of outdated. It had sort of paved the way for multi-engine, universals type airplanes that could do fighting and bombing. But it soon got superseded by the jet. Anyway, they got rid of 80 of them, flew them down to New Zealand and started flying them in 1948 to New Zealand. Most of them made it. And the ones that got to New Zealand, the RNZAF only used 20 of them. They had 60 spares. So we think that this one we can't find any evidence that it actually was one of the operational airplanes with the RNZAF, but it definitely arrived in New Zealand. And it may have gone into storage with a whole lot of others. And then in 1952 or 3, I can't remember exactly which one it was, the government stores board in New Zealand decided that the Mosquito for them was finished as well, and they were being replaced with jets, and they auctioned them off. And a company from California bought 6 of these Mosquitoes for aerial survey work in California. They prepped this airplane in Palmerston North in New Zealand for the ferry flight up to California, registered it on the civil register in New Zealand, and then the day it left, they registered it with the FAA and took off heading for California. So they sort of island hopped their way up and finally got to Hawaii. It took 11 days, I think, in total to fly up to the US. And in that period, that 11-day period, word had got out that a private company in Southern California was importing these aeroplanes, and the government got involved and halted any further shipment of them because they were fearful that they would end up in South American hands for covert operations. So the rest of the airplanes...
As in American intelligence? Is that what you mean?
Yeah. I think
the
that's...
company.
Yeah, if you can say American intelligence in the same sentence. But I'm only kidding.
Ooh, take that.
Anyway.
Well, partly you were kidding. I know. Yeah, all right.
So it was the only one to make it. It operated in California for a little while, but then unfortunately the company that, fortunately maybe, the company that was operating them got involved in an insurance scam. They had another B-35 airplane, and the owner was struggling financially, and he cooked up an arrangement with this pilot whereby the guy would fake that he had an engine problem and fly out over the coast of California there and jump out and let the airplane go into the sea, and they would be able to claim the insurance. But whether it was deliberate or not, the airplane suffered an actual problem, not a fake problem, and it crashed in the hills at the back of California, back of Los Angeles, and killed the pilot. Well, in the short term, he got paid out, but in the long term, he got found out that perhaps he was responsible for the reason the aeroplane had crashed, and he ended up in jail. But this aeroplane, which was sort of collateral for the loans and what have you, ended up being impounded by the insurance company that had paid the money out. And it got parked at Whiteman Field in Burbank and just basically left there for the next 25 years. It wasn't being, well, they weren't paying any ground rent, and it just became more and more dilapidated as time went by. Just sitting out on the edge of the... outside on the edge of the field. There were a number of other airplanes that I don't know about this airfield, but it seemed like a bit of a dumping ground for old airplanes back then. And right up until the 70s, it was just that became more and more derelict, more and more pieces stolen off it by souvenir hunters, and kids would go and play on it. And, it became quite a sorry sight. And then there was a plan to take it to Ed Maloney knew about it, and there was a plan Ed had hatched to take the airplane to his museum, but for one reason or another that never happened. And the guy Jim Merlin, who was an A4 pilot for the Navy, he saw it. He'd fallen in love with the Mosquito and decided that somebody needed to save this airplane and rebuild it. And so in 1971 he went out with a big low loader and loaded all the remains of this terrible looking aeroplane onto it. And
did he buy it? He bought it?
Yeah, I think he bought it off the airport company, who had taken ownership of it in lieu of unpaid parking fees for the last 20-odd years. I don't actually know what he paid for.
Any idea what he paid for it?
I'd like to know what he paid for it, but he probably won't tell me. So then it was more or less saved, I suppose, from the ravages. He stored it, and with lots of plans of eventually rebuilding it. But like a lot of these, ideas and people that do these wonderful things back in the time when there was no industry like this, it was a great idea, but he didn't have the resources that needed to do it. Although he definitely had the desire, and but he'd done the critical thing in that he'd saved it. He got it inside, mostly, so began its sort of rebirth.
And what year was that?
So that was in 1971, and he managed to hang on to it until 2014, when so he had it for a long time, and it wasn't easy to get it off him. He did not really want to let it go, and it took quite a bit of convincing
Who did the convincing?
Simon Brown was heavily involved in bringing Jim and myself together, and we kind of, you had to impress upon him that that a lot of these projects are all about timing, and that the timing was right for his aeroplane. There was somebody that wanted to rebuild it who had the money to do it. There was a company like ours that had the ability to do it, and there was his project that could be the start of it all. So these things only come together not that often. There's a lot of people with projects and a lot of places that can do them, and a few people with the money, but
timing.
You got to get them all on the same page or in the same bar at the same time.
Right.
Anyway, he finally, relented, and almost with a tear in his eye, saw it disappear into a container on its way down to
Now,
New
did
Zealand.
this have a public cost at this point? Does anybody know what was paid for it?
Does anybody know?
Yeah.
Oh yeah. The guy that paid for it knows,
Yeah.
but he's not here.
But do you know what it was, the cost?
Yeah, but he asked me not to tell you.
Oh, well, okay, we covered that. So what happened to it? Where was it shipped?
One of the most amazing things about this aeroplane that doesn't happen very often with World War II relics is that its original engines were still with it.
Yeah.
So in spite of the fact that a whole lot of cool stuff had been souvenired over the preceding 70 years, the engines on their engine mounts, still with their exhausts and cowlings and everything.
Cowling and the spinners. Everything is
yeah.
original.
It was all still there. So we sent the engines because the rest of it was going to New Zealand and the engine shop was in California. It didn't make any sense to take them down there and send them back. So Jose Flores from Vintage V12s drove down from Tehachapi with his big trailer, and we popped the engines on the back of the truck. Off he went. So this is early 2014, and everything else went into the container.
So did you have to bust the airplane up or carve it
Well,
up?
by the time 2014 came around, it had been pretty well busted up.
Yeah.
And it was most of the metalwork had been stored in a container off-site, but the wings and remains of the fuselage were at Chino at that time. So we just gathered up everything we thought that was going to be of use to us, stripped everything else off, and stuck it in the box and sent it to New Zealand. Which, by the way, gave the Ministry of Agriculture a bit of a shock when they opened the door and looked inside.
So
wow,
it's there.
really?
So this is
That's an airplane?
2014?
Yeah, so this is in 2014.
So this all arrives except the engines, right? And what was the process then? What happened then?
Well, the woodwork part of it had already been kind of taken care of. Well, it hadn't started on this job, but the process of restoring the woodwork and building new fuselage and wings and what have you had already been perfected, and the process sorted out pretty much on the previous two that we'd done. So this is the third aeroplane that we've managed to do, sort of since the process of Mosquito restoration has taken place. We started that first one in 2005, and it didn't fly until 2012. So the first one was a 7-year project. The second one was a sort of 5-year project, and the second one is now flying in Seattle. And this one turned out to be 4 years. So we learned a lot about how to do it, and found a whole lot of the missing information that we needed and all that kind of stuff over the preceding, however many years that was. So the process was a bit more straightforward. But yeah, woodwork began and trees were cut down and all that sort of stuff. Plywood manufactured. Yeah. And the reconstruction of the fuselage and wings takes place first. And while that's going on in the woodwork shop, we're getting on with overhauling all the components and preparing to kind of put it all together like a big jigsaw puzzle.
But you already had the molds, the jigs, you were ready because you had the experience with two earlier airplanes.
Yeah, exactly.
Yeah.
Well, that's why it's so much, a shorter calendar period anyway.
Right. So how many of these are still flying in the world?
I don't know. There's 3 basically here in the U.S. that are flying. There's 1 in Canada that can fly and has flown, but it hadn't been flown in a while.
Yeah.
That's what we've got here.
Yeah, hasn't flown since
Europe,
2015.
I don't know.
Yeah, no, there's nothing else anywhere else. So there's the 3 here in North America and 1 in Canada, yeah.
So as far as we know, there are just 4 in the world.
4, 3 actively flying.
Now there's one here at the museum.
Yeah, the one here at the EAA museum.
But it can't. I wouldn't fly it.
Yeah. So Sam, what are you hearing now? As you're the aviator here.
Well, I don't know it. I don't think I'm on.
Yeah.
Hello.
Hello. Hey, Ron. No, I'm talking to Ron and sound. Ron, can you hear me?
Hello?
Sam's mic isn't working. I'll repeat. Yeah.
Okay. Initially, did the government contact Havilland to develop this airplane, or did de Havilland have to develop it on their own and then convince the British government that they wanted it?
Yeah, the question from Sam is that originally, with this airplane, this design airplane, did de Havilland do it on their own and then sell it to the British government, or did the British government come to de Havilland and say, develop the airplane to these new specs?
Within these specifications.
You're good,
In other
yeah.
words, how difficult was it?
Yeah.
Yeah, well, I think what the process was at that time is that the Air Ministry, as they were known as in the UK, would put out a specification for an aeroplane. It might be a fighter, a bomber, or a liaison, whatever it might be. And the specification would say that we're looking for a bomber that'll, can cruise at 285 mile an hour and fly 1,200 miles and carry X number of pounds of bombs, etc. So a specification was issued for a light bomber. And de Havilland we're looking to get into the market, obviously, because there's a lot of airplanes being manufactured, and it's a good time for companies making airplanes if you can get an order. So the problem they had was that everybody had been telling the Air Ministry and everybody else that would listen that the metal airplanes were the way of the future, and the Spitfire and the Lancaster, all these other airplanes which were made out of metal were the way things were going to go. But their design was sort of a bit like turning back the clock as far as these military people were concerned, and they didn't want to know anything about it to start with. They rejected the offer from de Havilland right at that very first early stage, and in a lot of cases that would mean the end of it. If you don't get funding for a prototype, it doesn't happen. But de Havilland were building Tiger Moths and a whole lot of other, making money in other areas.
Mustang?
So,
Is that a Mustang?
yeah,
Mustang.
Sound of freedom.
So de Havilland.
Yeah, so de Havilland decided that they had so much confidence in the design and the fact that they could meet the specification or exceed the specification that they would take a punt on building the prototype themselves without an order and without any funding from the government. So in an 11-month period, and this is quite incredible, in an 11-month period from being rejected, they had the prototype ready to demonstrate to the Air Ministry in the UK. And 11 months from a design from just a concept drawing on a piece of paper to drawing it all up, building it, having it ready, a completely new design. And then on top of that, not only was that quite a remarkable achievement in itself, they had no airfield where their design office and manufacturing prototype building place was based. It's a place called Salisbury Hall in St Albans, just about 25 miles by air north of London. And Hatfield, where the de Havilland factory was 5 miles away, but Salisbury Hall, where they built the prototype, had no airfield at all. So in this 11-month period, they draw up the airplane, build the prototype, pull it apart, put it on a truck, take it to Hatfield, put it back together again, and test fly it.
My gosh.
So, yeah, I mean, it must have been an amazing time for them. Oh, plus, while the bombs are raining down, of course, because now this is in 1940, and, shit's getting real. Anyway, they did a really, really fantastic job. The aeroplane exceeded all their expectations. It was faster than they expected it to be. Turned out to be lighter than they had planned. And when they demonstrated it to the British, even though they still had some problems, and there was a guy, Freeman, who kind of campaigned on their behalf with the Air Ministry to take this aeroplane on. They finally got it approved, and orders came in for a bunch of first production airplanes, and away they went.
How much of the ability to go from paper to a flyable airplane was because it was basically made of wood? Did that cut down on the
yeah, I guess it would have.
building time?
For the same sort of things I was suggested before, that you don't need a massive amount of tooling.
No.
I mean, with the way the fuselage is built, you do have to have a mould. But one mould can make multiple aeroplanes because it's not on the mould for very long. But for those that don't sort of realise the way the Mosquito's built, it's a lot like your normal model aeroplane might be. Fuselage is joined vertically down the top and bottom, so it comes together in two halves, just like a model aeroplane would. And so the mould is a male plug with slots in it, a little bit like a toast rack, to hold the 7 bulkheads. And then the plywood's laid over the outside of this male mould and held down with metal bands. So you do need to have a mould, and the two halves are eventually pulled off the mould and joined together. So they made a number of moulds, and some of them were made out of concrete. And away the production went. But because so many of the components were just built off a set of full-size plans and chopped up out of pieces of wood, it didn't take a lot of preparation to be ready to go into production.
In the mold situation, did the wood have to be made damp or wet in order to mold it or not?
Well, the fuselage is only made out of 1/16th of an inch thick plywood. So it's slightly over 1/2 an inch thick in total, the sandwich, but it's got 1/16th plywood on the inside, more or less 1/2 an inch of balsa wood or spruce laminated members, and then another layer of 1/16th inch balsa wood on the outside. And, it's made in multiple pieces that are spliced together.
Right.
Scarfed together, rather. So it does sort of wrap around it pretty well.
Right.
And the nose, which has got the greatest amount of sort of shape in it, it's strip planked, if you like. So a bit like you might have seen, vintage boats have got beautiful mahogany strip planking in order to get the curve. Well, they did the same with the plywood on the nose. But sometimes you have to steam it. The leading edge of the wing, which is a tight radius, that's formed by steaming.
Right.
But generally dry.
Well, you said that they were concerned about going back to wood, I guess because of the deterioration. Did they have any problems with the glue on that when they first started building it and they had to leave them outside? They couldn't be in a hangar?
Yeah, well, the original Mosquito was built from casein glue, which was a furniture manufacturing glue, which is a made from a milk byproduct. And while it's a good glue, it's strong enough. It wasn't particularly waterproof, and so there was increasing issues associated with water getting into the glue joints and some glue failures. But then this idea of synthetic resin was developed at the same time, and the Mosquito was the first sort of mainstream use of synthetic glue, which at those days was a urea formaldehyde glue, which was superior to the casein, but still has got some water absorption issues that have prevented most airplanes from that era that were glued together with urea from still flying today. So when the airplane got into operation in the islands, like they operated them in Burma, and you know what it's like if you've ever been to the tropics. Every afternoon at 2 o'clock there's an enormous downpour. Well, the escape hatch on the Mosquito is a big square panel above your head that you can get out if you can't open the door. And because of the nature of it, it leaks water in a very heavy volume of rain, and the rear edge of it just happens to be right over the main spar of the wing, which is a bit unfortunate. So the water drips through and soaks into the main spar, and they did have some failures in Burma with that, but they figured out ways to mitigate that problem. But of course nowadays we don't use that type of glue, and the modern glue is sort of 100% waterproof, so we don't see any long-term issues with the glue any longer.
Right. Engines, I'm wondering about. I'm sitting looking up at these two engines that you said were the original engines.
Yeah.
What are they?
Well, they're Rolls-Royce 25s, so that's basically a single-stage Merlin. Basically the same motor as you see in an early Spitfire or a Hurricane or in a Lancaster bomber. So they made two versions of the Mosquito, or two engined versions, one with this motor, which is a sort of low-level engine, not highly supercharged, so it doesn't have an intercooler and only has a single-stage supercharger. And then they built the higher altitude ones for the long-range photo reconnaissance and bombers, and they have a two-stage engine with an intercooler, just like you would find in a Mustang.
Right.
When they built the aeroplane in Canada, they had a Packard in them, but the British-built ones all had Rolls-Royce engines. So Rolls-Royce Merlin 25, 1,610 horsepower.
Was there any difference between the three manufacturers?
Yeah, the airplanes that were built in Canada, they made some changes, I guess, from a supply perspective. They used Packard engines to start with, and they also used American designed instruments and electrical plugs and switches and things like that. So if you get in a Canadian built one, it's got GE instruments and normal switches you might find in any other American airplane, and Canon plugs instead of breeze connectors. So yeah, differences in the electrical and instrumentation, but pretty much everything else was
How about quality
identical.
control? Was it about the same?
Well, I don't really know. We haven't noticed any difference between them. But then we have only seen a few
Right.
handful of them.
Well, you mentioned inside that really it was like as far as a composite airplane, it was similar to the construction of a 777. Is that correct?
Well, the point I make quite often is that the way that the Mosquito was designed back in 1940, utilizing a sandwich skin construction where you've got a stressed member on the outside and inside, in this case plywood, and then a soft, lightweight medium in between to hold those two skins apart, which is exactly what modern composites are. This aeroplane was really the first production of use of that type of construction. And it resembles, a Dreamliner's construction far more than anything else has between World War II and now, in as far as mainstream production's concerned. This type of sandwich skin construction has become the way of the future, but it's taken 75 years to happen. Yeah, I mean, there's lots of examples of it out in the field with the home-built aeroplanes, of course, because they had the ability to make use of that. And all the composite stuff that's out there now really leans on the development and design of this aeroplane from all that time ago.
I'm looking between you two, and I realize the tail dragger,
Yes.
right? How much does that affect your flying it in any way, shape, or form?
Well, you need a little tail wheel experience for this one, and it does not have a locking tail wheel. So once you set it down, it can go either way. Now, you got to get used to the British brakes, because you displace the rudder and then you grab a handle to put the amount of brake that you want in to correct. So you're doing a lot once this thing gets on the ground. But it's really pretty tame. It's not a bad airplane. It's not like a 109 or anything like that that's liable to turn any direction at any time.
Sam, as you're listening to that about flying it, would you like to try to fly this airplane?
Oh, of course. Yeah. Oh, yeah. Oh, yeah.
What would he be dealing with? I mean, he's got 35,000 hours in lots of different airplanes. But
Like I say,
huh?
you have to be a pretty good tail wheel pilot to do this one. If you're not, you have to anticipate what's going to happen to you and get the feel of the brakes. And once you got that, it's just a tail wheel airplane. It doesn't have oleo struts in it, and it has no fluid, no air. They're pieces of rubber. And with the big balloon tires and everything, it lands soft. It's just as nice as you can. Yeah. So it's good, but with a tail wheel that doesn't lock, it can turn any direction at any time.
Yeah.
Do you three-point it or do you wheel end it?
You can three-point it. I usually wheel land it because that gives you positive control with the rudder to get set for the brake ride that you're fixing to have. But it's 100 knots, over the fence.
What? Q&A? Yeah.
Right now, we've got a little bit of time here for Q&A, some questions and answers. We have two people here with mics. If you'll wait till they bring the mic to you.
Thank you. Is it on? The P-38 Lightning had counter-rotating propellers. Why do you think de Havilland went with non-counter-rotating propellers on the Mosquito?
Well, the P-38 has a different tail on it than this does. Okay, that's what affected the P-38. This thing, believe it or not, you can, and it's in the manual. This is the way that they did it, and they figured it out. You set the brake, your hand brake, you hold it, you take the engines and you go to zero boost, which is basically 30 inches. So that gets the props up. Let go of it and go max to 14, and it stays straight.
Wow. Wow.
Next. Up here. Yes, sir.
What was the maintainability?
Hold it close to your mouth, please.
What was the maintainability of the plane during the war in terms of damage and repairability because it's wood?
Well, it's a fighter, it's a bomber. They did it all. And that's the neat thing about the Mosquito, is it was multiple.
In terms of fixing bullet holes and damages because it's wood, was it harder and how would you go about fixing it, to patch the holes from impacts?
I didn't hear the first of that.
Did you ask, was it difficult to repair?
Yes, because of the wood.
Well,
Bullet holes.
I don't know how difficult it was for them, actually. I guess you're not going to have molded pieces of plywood ready to go on if you're out at a field base, but trees pretty much go anywhere, so perhaps you could just go out and find yourself a bit of timber from any old where and slap it on. But so I'm not really too sure how easy or difficult it was, but it was known by the people that operated to be the kind of airplane that would always get you back home. Even though you might have suffered some terrible damage, and there's some wonderful pictures of airplanes making it back to base with huge chunks of wing blown off and enormous great holes in the rear fuselage. I think part of the reason why it was able to take a lot of battle damage is because it's truly a monocoque fuselage, and you could blow a big chunk of it out and you wouldn't take out a main member. There were in some cases, bullets would go through some part of your fuselage and the tail would come off. But on the Mosquito, I think because it's such a monocoque design that you could blow a big chunk of it out and it would still hold together. So it wasn't known by its crew as being a very robust airplane and one that was capable of getting you back home, pretty well.
And it flies really well on one engine. Your critical time, of course, just like any multi-engine takeoff, is right after takeoff. But if it's up and going and you feather it, clean it up, and everything, so they could limp home on one.
Yeah.
Yes, sir.
Could you comment on how stealthy it was, or what the radar signature looked like, say, compared to its contemporaries like a P-38?
I don't know.
Weren't you there?
Huh?
Oh, sorry. Yeah. Well, I don't really know. I guess the propeller and engine is going to be your big problem. Doesn't matter what you make the airplane out of, the propeller and the engine is still going to be a pretty big part of it. And curiously enough, that even though it's a wooden airplane, it's also full of literally miles of copper bonding strip. So there was obviously an issue with static electricity build-up, and the company went to a lot of trouble to bond every piece of metalwork to every other piece of metalwork. So if you get an opportunity to look up inside the bomb bay or any part of it that's wooden,
and that's one of the neatest things on this airplane. Y'all need to look at it. Is the bonding and everything. It's absolutely perfect.
Yeah. There's copper strip, varies from 1/4 inch to 1/2 inch thick, depending on how many sort of components are connected to it, and it's all nailed on with a little brass brad. And so the whole airplane is literally covered in this, spaghetti of copper bonding strip, and that probably doesn't help with this radar signature. So, yeah, it's probably not as good as you think it's going to be. You sort of think because it's a wooden airplane, it might have been hard to pick up on radar, but The reality of it is it's full of wire as well, and that all just escapes through the timber just as easy as anything else. So I guess it probably wasn't as good as you might think it was.
One more over here.
Hello.
Yes, sir.
We know that it could outrun most fighters, and a New Zealand pilot operating out of Burma once wrote about being chased by Japanese fighters, and they just opened the taps a little bit and just went a little bit faster than the Japanese fighter. And he said eventually after about a quarter of an hour you'd see a puff of smoke when the engine blew up and they were gone. But could you tell us, in its fully bombed up weight, how much it could carry in its full weight?
How much what?
How much bombs could it carry?
I don't know how many bombs it carried. It carried a whole lot of armament with the guns and everything, but I've never seen them count on the bombs that could be fit up in there.
This example came out at 14,666 pounds empty, and in the war they got them up to 22,500 odd pounds. So of course a lot of that's taken up with fuel and what have you, because it carried a lot of fuel. But the biggest bomb load it carried was a thing called a 4,000 pound. Yeah, it carried a 4,000 pound cookie bomb. They couldn't fit it in the. Probably the biggest shortcoming of the airplane was the size of the bomb bay. It, with all the power it had and the ultimate performance it had, you couldn't really fit much in there because it's quite small. So if you get an opportunity to have a look at Kermit Weeks's airplane down at the EAA Museum, you'll see that it's got a sort of swollen belly on it, and they moved the bomb bay doors down close to the ground and fattened it out so they could fit this 4,000 pound bomb they called a cookie, which kind of looks like 3 55-gallon drums joined together, this big, long, ugly barrel, and that weighed 4,000 pounds. So, that's quite a bomb load for an aeroplane like this with a tiny little 50-foot wingspan. They say that it carries the same bomb load as a B-17, but those sort of numbers are kind of not necessarily telling the real story. It could carry it, but it wouldn't go as far.
Yes, sir. One last question.
Yes, you hear stories about planes or remains of planes being found in strange places. I was just wondering, are there any rumors out there or stories that there's still some of these hidden places or could be out there in the jungles or somewhere? I'm not looking to buy one. I just curious if there's any more remaining to be restored.
Well, there wouldn't be much left as far as the wood. You would have metal parts maybe, and there'd be, depending on where it was. But finding something like that, it gets harder and harder every year.
Probably what you say is true. There is the opportunity for aeroplanes to be, discovered in different places. But I think the bigger the aeroplane gets, the less likelihood there is of being able to find one that nobody knows anything about. And then if it's made out of wood, well, then there's even less chance that it's still going to survive. So there may be airplanes out there that could still be discovered, and hopefully there are for a company like us, because that's what we need. But I doubt there'll be mosquitoes because, they're just too big to hide, and you can't leave them outside. They end up just falling on the ground.
Well, one last question in regard to that. The P-51s, there are people that are remanufacturing P-51s with just the data plate. Do you intend on doing that with the Mosquito?
Well,
you got all the molds.
It sounds like you're looking for one. Are you?
Yeah, really.
There's even with this airplane here and the amount of stuff that we had to start with, which was a considerable amount. It still takes in excess of 80,000 hours of work to restore it from an original project, and in anyone's terms, 80,000 hours is a lot of money. So if we were to start making everything, building new wheels and landing gear and engine mounts and all the other literally thousands of metal components, the price would just go so far out the roof that it wouldn't be practical. Yeah, it wouldn't be practical. It would be, it's hugely expensive now, relatively speaking, and it's the idea of doing it from scratch. Don't think it's going to happen.
Thanks, both of you. We really appreciate your information and bringing your beautiful airplane here.
Many of the world's greatest combat aircraft have been born not as a result of some officially inspired specification, but because of the unshakable conviction of one man or group of individuals in a revolutionary idea. No better example of this could be cited than the de Havilland Mosquito, which diverged so far from the official views pertaining at the time of its conception that this magnificent aircraft was almost never born at all. With the prospects of a world war looming, the designers of de Havilland quickly realized that the metalworking industries were going to have their hands full. The materials and manpower of the furniture-making industries were not going to be needed. Rather than these resources going to waste, why not build a wooden aircraft? Furthermore, the concept was to build a bomber with fighter instincts and an aircraft that could carry a substantial bomb load. Its main defense against enemy fighters would be its ability to outrun them and outmaneuver them in combat, something that the Mosquito's rival in the Royal Air Force, the Bristol Blenheim, severely lacked. It was the de Havilland Company alone that could take full credit for this aircraft. For against all of the opposition at the time, they went ahead with their belief in the rightness of this formula, and produced, for the Royal Air Force, one of the most potent weapons of the Second World War. The essence of the Mosquito was that the combination of many proven elements, 2 Rolls-Royce Merlin engines, the smallest practical airframe, extreme aerodynamic cleanliness, and a high power-to-weight ratio. The result was a flying machine which surpassed any other operational aircraft available at the time, and its most amazing attribute was its incredible versatility, which, as the war progressed, resulted in the aircraft being known as all things to all men, a claim which took until the introduction of the Tornado decades later to rival.
Now we had an airplane fast, which could fly on one engine. All other twin-engine airplanes, you had to struggle to keep them in the air on one engine. You could actually climb on one engine in a Mosquito. That was in the early days. As they got heavier and heavier and bigger bomb loads, then the single-engine performance wasn't quite so great. But it was still a wonderful airplane, and it was by far the bomber that flew the highest of any bombers in Bomber Command.
The Mosquito was a high-wing cantilever monoplane. One-piece wing slightly swept back at a leading edge and sharply tapered tailing edge. The center portion of wind carries the engine's mountings and radiators. The wing's fuselage and tailplane were all of wood construction, with laminated spruce flanges and plywood webs. Pinned, glued, and screwed, and finally covered with fabric. The final version of the Mosquito ended up with a wingspan of 54 feet, a length of 44 feet 6 inches, and a height of 17 feet 5 inches. The wing area was 454 square feet.
We attacked all sorts of targets on the ground, tanks, lorries, trains, bridges, and some of the more important targets like the Gestapo headquarters in Copenhagen. We had to attack those at 0 feet by placing the delayed action bombs in the front door. This was done so as that the political prisoners that were being kept on the top floor by the Gestapo to try to stop us from bombing the targets from above, we put the bombs in the front door so that no harm would come to these political prisoners, which the Gestapo held. This sort of raid was done on several buildings. As I say, the Gestapo headquarters in Copenhagen, the shell building at The Hague, and a similar type of raid was carried out not by my squadron but by Group Captain Pickard on the Amiens prison when they breached the walls surrounding the prison and also breached the prison walls to enable 200 to 300 French political prisoners to escape the day before they were due to be executed. This was not my wing and not my squadron, but it was another example of the type of low-level bombing which the Mosquitoes had to do.
The landing gear is fully retractable, and the unit's air brakes are both hydraulically operated. The aircraft was powered by two Rolls-Royce Merlin 12-cylinder V liquid-cooled engines. The reconnaissance and fighter versions had a range of over 2,000 miles and a ceiling of over 36,000 feet. The accommodation in the fighter and fighter-bomber variants was side-by-side seating for two crew members with an armor-plated bulkhead in the nose and a fat bulletproof widescreen. Entrance to the cockpit was through a door on the starboard side. In the bomber and reconnaissance variants, there was also accommodations for a crew of two, with a perspex nose section and a V-shaped windscreen. Entrance to the cabin was through a hatch in the floor. The possibility of developing a fast, light bomber was first investigated by the de Havilland Company in the summer of 1938, by which time the company had been concentrating on the design and development of a civil aircraft for some 15 years. In May the previous year, the beautifully proportioned and perfectly streamlined Albatross had begun its flight trials. The success of this aircraft, with its ability to carry a heavy payload at moderately high speeds with very low fuel consumption, led to a study of its military potential as a bomber, and furthermore into a complete study and analysis of the potential use of light wooden aircraft, carrying heavy loads at fighter-like speeds. The nucleus of the idea developed into a wooden monoplane powered by two Merlin engines, capable of flying in speeds of excess of 400 miles an hour. With the outbreak of war in 1939, the design effort into this project was doubled, and the Air Ministry interest was starting to develop. After considerable deliberation, the design team's preference for a crew of two and an aircraft completely devoid of defensive armament was officially accepted, and the basic requirement for a minimum of a 1,000-pound bomb load and a range of 1,500 miles was agreed. The design team were given a completely free hand. However, on the sheer farsightedness of that design team, they produced plans from an aircraft from the outset, with provisions for guns or cameras, so that in any eventuality it could serve equally well as a bomber fighter or photo reconnaissance aircraft. On the 1st of March 1940, an official order from the Air Ministry of 50 aircraft reached de Havilland. The number was relatively small because of the still only lukewarm interest in its potential, and the realization that alternative aircraft might well be developed, which would render the committing of one type to large-scale production from the outset might be a somewhat short-term policy. In fact, for several months after the placing of the first order, the future of the whole Mosquito program remained in jeopardy. In that period of the war, when the whole future of Britain hung in the balance, it was natural that all efforts were placed on producing aircraft with already proven qualities, and a machine which, in some places, was regarded as simply a pipe dream should remain at the bottom of the priority list. But de Havilland pressed on with the prototypes, only able to do so because of the DH-98. As it was designated, made so few demands on strategic materials which were desperately in demand by other manufacturers. Three out of the 50 aircraft ordered were designated for prototype trials, and against all odds, production went ahead on them, whilst all of the materials and parts of the remaining 47 were assembled. On October the 3rd, 1940, 4 bombs dropped from a Junkers 88 and hit the de Havilland plant at Hatfield and destroyed over 80% of the production materials. By good fortune, no damage was suffered by the prototypes. The name Mosquito was adopted for this new aircraft on November the 25th, 1940, less than 11 months after the first detailed design. The first prototype made its maiden flight at Hatfield, with Captain Jeffrey de Havilland Jr. at the controls. The aircraft performed magnificently. The subsequent trials soon proved the astonishing agility and capability of the Mosquito, and there were few doubts left as to its potential.
Also, there were discussions about increasing the load by cropping the vanes of the standard 500-pound bomb. 4 of this size, instead of the 4 250-pounders, would be housed in the same bomb bay. And so the design load was doubled before ever the aircraft went into service. The designers had provided for 4 20mm cannons in place of the bombs, which, together with 4 machine guns, gave a concentrated and destructive firepower.
Interest by the Air Ministry, having seen the test flights, now favored the fighter version. The order was changed to only 20 of the bomber variants and 30 fighters. Construction of the fighter prototype proceeded at Salisbury Hall, just outside of London. This served as a dispersal for the Hatfield factory and an experimental shop. The Salisbury Hall is now the home of the Mosquito Museum. Meanwhile, the bomber prototype had already undergone extensive trials at Hatfield and had now been handed over to the RAF for official testing. Between the prototype and production stages, only one major modification was made, which was the extending of the nacelle fairings to improve the airflow. In July 1941, the Mosquito was known to be a winner, and de Havilland were told to prepare for large-scale production in their own factories and also make plans for production in Canada. The third prototype had been tested as a reconnaissance aircraft, also with great success, and the initial order for 50 Mosquitoes was now divided into 10 bombers, 10 reconnaissance, and 30 fighter variants. There was also a proposal for a dual-controlled trainer version to be prepared. The first Mosquitoes entered service with the RAF in July of 1941. The first operating sortie was made on September the 20th, 1941, 21 months after the start of design. But this sortie was never a bombing or fighter mission. A camera-equipped Mosquito set out unarmed, photographing enemy harbors from a height of 4.5 miles. With high photographic skills and determined flying, the Royal Air Force developed long-range reconnaissance at top fighter speed, something that the enemy was never able to achieve. All Europe thus became within range of the cameras, which brought back pictures of microscopic accuracy that defeated every ingenuity of camouflage. The perfect view of a Norwegian hideout 1,000 miles from England. A Messerschmitt factory. The bomber, in which the armaments were sacrificed for speed, faces the test of reality. Its operational career began when 4 Mosquitoes bombed Cologne, a few hours after the first 1,000 bomber raids at dawn, May the 30th, 1942. From that first day's work, pilots believed that the best way to use such speed and maneuverability was to fly it in a rooftop height, where neither ground guns nor radio communications could concentrate upon them. The technique was perfected.
Enemy coast coming up. Something behind. Looks like a 190, about 1,000 yards away. I've got him. Take out. What's happening now? Still there. Keep going. Okie dokie. They've given up. Miles away now. Gosh, we could have pinned his ears back if we'd had some guns.
Home sweet home. They bombed the target, the whole target, and nothing but the target. British radio experts called for a fast aircraft capable of carrying apparatus for bombing accuracy through clouds. The Mosquito was chosen to carry this equipment, for it could fly far, fast, and high. The Pathfinder had to reach its target maybe 600 miles from home and fly rock steady through all the flat before dropping his marker flare. From May 1943, Mosquitoes undertook nuisance bombing at night. Because of their speed, they lost only 11 aircraft in their first 1,000 sorties. By early 1944, they were carrying 4,000-pound blockbusters, and the big city was their favorite target. By now, this very small aircraft was carrying to Berlin a heavy bomber's load, unarmed and without the need of an escort. It represented a small capital epic, with small crew exposed to less danger because of its speed and exposed to danger for less time, yet it carried a 4,000 pounds load, and carried it more frequently than the slower, larger bombers. Night after night, Mosquito crews were briefed for their ops, seldom missing 3 or 4 nights per month in bad weather. High-altitude engines and pressure cabins enables them to bomb from a height of 6 miles. This was no longer nuisance bombing, but systematic pounding by Mosquito blockbusters in strength, let in by their own pathfinders. Up to the spring of 1945, they had delivered 15,000 tons of bombs. Much of this fell on Berlin, visited for 36 nights in succession. The other half of the battle history concerns the armed Mosquito. After the first blitz had been broken by our bow fighters, Hurricanes and defense Mosquitoes took over the night defense of Britain. Radio location helped to find the enemy in the sky, and Mosquitoes, now with the improved equipment, got busy in 1943 when the enemy sent its fastest single-engine fighters to England with a puny bomb load, copying the Mosquito technique. But they failed, because our Mosquito fighters could catch these hit-and-run raiders. When the V-1 attack started in June of 1944, it was the Mosquito's jobs to destroy those missiles by night. They were far from easy to catch, but Mosquitoes got 620 in the first 9 weeks. Later, when the launching technique changed, they destroyed their launching pads as well. By the end of 1944, Fighter Command Mosquitoes had destroyed no less than 660 enemy aircraft. Mosquitoes have been on ocean patrol since the winter of 1942, seeking out submarines and destroying the long-range enemy fighters sent to Harris bombers, which were after their submarines that were after our shipping. Meanwhile, the rocket projectile was developed. No gun to carry, but a much more destructive missile. The rocket elbow of a Mosquito, 8 times 60 pounders, is equivalent to the broadside of a cruiser. Accuracy was the best feature of the 6-pounder, firing at a rate of 25 shells in 20 seconds. It was most effective against submarines and small shipping targets. Honor Command used Mosquito intruders to support their heavy assault in various ways, by escorting Lancaster and Halifax forces as fighter cover and by flying ahead of the main force over disorganized defenses. They lucked around airfields and shot down the enemy fighters on their own runways. From June 1943, Mosquito intruders worked as technical support for the Army. They took over the specialized methods of German attacks previously used by the enemy bombers. They didn't all get off scot-free. When a propeller had to be feathered to stop a damaged engine, it was sometimes necessary to jettison the wing tanks to regain a little of the lost speed. With the undercarriage damage, many a Mosquito landed on its belly, a cloud of dust and gas from automatic fire extinguishers. With the main entrance blocked, out came the crew by the fanlight. When the enemy was being driven across farms after D-Day, single-engine intruders kept them pinned under cover and Mosquito fighters smashed his movements by night. Aided by the lights of flares, they were out in their hundreds, night after night, and brought great havoc. Throughout the war, the Mosquito program underwent many new developments, and there were no fewer than 27 different variants produced. And apart from the more general rules, the aircraft rapidly became the subject of all sorts of experiments into fighters, bombers, and reconnaissance techniques. Throughout its service and war career, The Mosquitoes operating from the United Kingdom dropped just slightly less than 27,000 tons of bombs. They suffered fewer losses per 1,000 sorties than any other bomber command aircraft type, and an indication of their effectiveness was given in the attacks of the V-1 launching sites during 1944. One V-1 site was destroyed for every 40 tons of bombs dropped by Mosquitoes. Relative figures for the heavy bombers were approximately one V-1 site for every 200 tons of bombs dropped. The Mosquito ended its career on the last raid by Bomber Command of the war in Europe on attack against Kiel by Mosquitoes of the 608th Squadron on May 2, 1945. As a bomber of all-wood construction, the Mosquito was unique. And its multi-role variants, it was outstanding and it possessed that highly desirable but all too rare ability to make a pilot feel part and parcel of his aircraft. It was loved by the crews because more than any other aircraft in Bomber Command, it was the one that would get them home. It captured popular imagination from the moment its first daring sorties over Europe became known, and its sensational exploits continued to sustain worldwide interest and enthusiasm to a greater degree than those of any other combat aircraft. The Mosquito could carry phenomenal loads over extremely long distances, performing feats out of all proportion to the specification originally envisioned by its designers. In short, the Mosquito was an outstanding warplane on every count. And if perhaps it was overshadowed by the Spitfire as the most popular aircraft from the war at the time, the Mosquito was certainly the most popular with the men that flew them.
Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the Dronescapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.